So now today we're going to write our first overwriting DOS virus, and to do that we have to define how our virus is going to work. We have to plan out how our virus is going to work. So the first thing we want to do is search for a first file in the directory. So search first. Then after we searched for a first file in the directory, we could now test whether it's infected or not. So can we infect it? So can we infect? And if the answer is yes, we can infect this file, then we're going to infect it by writing to it. Then we're now going to search for a next file. So search next. And we're going to go back here. So this is our infection loop, as you can see. This is our infection loop. So search next, and then can we infect? And then if the answer is no, however, no, we're going to exit to DOS. Exit to DOS. So this is how our virus algorithm, how our algorithm for an overwriting virus is like. So now I'm going to switch over and write this virus using edit.com and assembling it using TASM, Turbo Assembler. So I'm going to find this. And now we're in our DOS OS and our DOS machine. And as you can see right here, the host files are working properly as the way they should. And now we're going to write our own virus. So over.asm. So we want to work within a segment. So we're not working between segments or more than one segment. So we will use the small memory model. And we're telling the assembler that everything below this line is all code. So we want to also tell the assembler that we're starting to write our code at offset 100 hex, and I'll explain why we want to do that when we get to what I call the disk transfer access, when we're going to talk about the DTA. So now we're going to tell the assembler that this is our entry point start, and we're now going to call some functions, namely the search first function, and that's for E. And then we want to search it with the following parameters. Like when you want to search a file, you have to enter the name of the file you're looking for. And now we're going to tell DOS that we want to search for all com files, and basically all com files is the asterisk.com. It's like when you want to delete a file, you say delete, and you want to delete all that files in a directory, and any file in that directory with the extension com. You do del and then asterisk.com, so offset com file. And then we run in 21 hex to tell DOS that we want to search for a file that's a com file, any file that's a com file. So all this data is going to be pasted into the disk transfer area. So now I'm going to discuss what the program segment prefix is. So over here I have so at offset 0 through FF, so this is 0 and this is 100. So at offset 0 through FF, I have what's known as the program segment prefix. Definitely not a video game console. So I have a program segment prefix starting from 0 through FF, not the game console. And at offset 80, that's the location of our disk transfer area. That's the location of our disk transfer area. Actually, it's 80 is also the address of what's typed after the command. So for example, if you were in DOS and you want to run a file with you want to run some file, and then you type in file and then text, and then say slash t or something like that, the slash t parameter would go at offset 80, would go to offset 80, would go at offset 80. However, when we run the search first function, all of whatever is at offset 80, including this command tail, is going to be overwritten with the disk transfer area. So we want to, if we want to preserve the command tail, we're going to have to locate our disk transfer area, because by default it's at 80. So in this virus we don't have to do that, so that's good, but in future viruses we may have to do that. So now at offset 1e into the DTA, so at offset 1e, that's going to be our file name. So the offset of our file name of this file returned by the search first function is going relative to the program segment prefix is 9e. So that's where going to that's what our DX register is going to be initialized with, to point to the file name. So now we're going to initialize DX with the file name located at 90 hex, and we're going to initialize AX with 3D01 because we want to write to the file with, open the file with writing permission. So open file with writing permissions, and over here we want to get the file name from the DTA. So now we could do N21H, and actually, if our file is not, if we cannot find this file, like say this directory does not have any files to infect, we're going to have to exit. And if the function finds no file, it's going to set the carry flag, and that means that the carry flag is going to equal to 1, and it's going to exit to DOS. So N21H, and then now we have opened our file, and the function gives us our file handle, so we have to switch the file handle around into BX. So we have to put our file handle into BX. So put file handle into BX. So now we're going to say that we want to write starting from offset 100H, because this is the virus. Our virus is starting from offset 100H, and we're going to have to say that the size of this virus is offset the end of this virus minus the start, and we're going to initialize our AH register with for 0H, because that's the function we want to write to our our virus into the host program. So we want to write our virus into the host program, and 21H, and then now we're going to close this file with AH equals 3E hex and in 21H, and then we're now going to search next. Jump search loop. Infect loop. So our infect loop goes right here, because if the file, if we have exhausted all of our files in the current directory, we want to go to this instruction right here, which would jump out and return control back to DOS. So what do we have to define? We have to define what exit DOS does, and that's the standard exit command. And I'm going to save it just in case if any internal stack overflow error occurs. And now I'm going to define what com file is. So com file db asterisk.com, because we want to search for any com file to infect, and 0 hex because we want to because the function asks us to provide the searching parameters with a null terminated character. So there, and that's our that's the entirety of our virus. Now we're going to have to say that nvirus is right here. Nvirus is right here. So we're going to tell TASM that that our entry point is at start. So nvirus is right here, and then you can see that the greater offset minus the lesser offset would give you the size of this virus. So size of our virus is in CX. So now that everything is good, I believe we should now assemble this file. So TASM over.asm, and it reports that there is no error, and which is good. And now we're going to link this file using the /t parameter because we want to create a com file. So over.object, and TurboLink reports no errors, which is very good. And now when we let's run our host first to see what it looks like before the infection. So hello world YouTube, I'm just another host. It does what it's supposed to do. And now we're going to run hello world YouTube, and that's what it's supposed to do again. So we're now going to run our virus, and it prints out nothing. So it does what it's supposed to do as well. And now you could see that our hello world YouTube.com file grew because whenever you have a virus that's larger than your host, an overwriting virus will overwrite all of the hosts, so now that host file grew in size because it has to accommodate the size of the virus. So now if we run hworld2.com, nothing happens. If we run hworldyt.com, nothing happens. So clearly the function of the host program has been disabled, has been overwritten by the virus. All of the virus code has been injected into the host. It's like pasted all over the host.